Drinking water treatment. Describe at least 3 reasons why we treat water. Answer: we treat drinking water because water in the natural environment usually contains many contaminants which make it unsuitable for human consumption. These contaminants include pathogens and chemical or radiological contaminants. Other characteristics of the water, including color, taste, and odor, may be unappealing to the consumer. The characteristics of the water may cause engineering problems. Label the major steps on the diagram based on conventional surface water treatment plant. This here is the diagram. And number 1, intake. Number 2, screen. Number 3, coagulation chemicals. Number 4, rapid mixer. Number 5, flocculation. Number 6, clarification, sedimentation. Number 7, filtration. Number 8, disinfectant, primary inactivation. Number 9, disinfectant contact time. Number 10, clear well. Number 11, disinfectant, secondary disinfection, followed by the final stage, number 12, to the distribution system. What is the purpose of the rapid mixing shown in the diagram? Answer: to quickly and thoroughly mix the coagulant chemicals into the water. Which of the treatment processes shown in the diagram above relate directly to public health and why? Answer: disinfection, coagulation, flocculation, sedimentation, and filtration are all relate directly to the protection of public health because they all contribute to the removal or inactivation of harmful microorganisms or contamination. Slow mixing to build floc is done in which of the treatment stages? Answer: the flocculation process. Describe the key difference between the purpose and process of coagulation versus flocculation. Answer: coagulation is the rapid dispersion of coagulant in water to destabilize particles and form precipitates or floc. Flocculation is the gentle agitation of water to promote contact between particles formed during coagulation to form larger floc. Define detention time. Answer: the time water remains in a tank is known as the detention time. Name 2 reasons why suspended particles should be removed during water treatment process. Answer: suspended particles should be removed during the treatment process to remove harmful particles, pathogens, and other contaminants, as well as to ensure that pathogens are not shielded by particulate during disinfection, increasing the efficiency of the disinfection process. Describe how filtration works and what materials are used. Answer: the tiny pore spaces in the filter media trap the particles in the water. Filters typically contain layers of anthracite or granular activated carbon, sand, and gravel. What is the purpose of a jar test, and for what stage of the process is it usually used? Answer: jar tests are used to determine the optimal chemical dose by simulating the conditions in the plant at a small scale. Jar tests are typically used for the coagulation-flocculation process. Describe the purpose and method of backwashing. Answer: backwashing is used to clean the filters. During this process, the normal water flow is shut off and treated water is pumped up backwards through the filter media to remove the entrapped matter. Excuse me. Which of the following factors is the most important for ensuring that chlorine has effectively inactivated microorganisms? Sufficient heat, sufficient time, sufficient oxygen, or sufficient pressure? Answer B, sufficient time. Chlorine effectiveness is assessed using CT, concentration times contact time. It is important to understand that CT, or contact time, needed to achieve the required level of inactivation. Define aeration and why it is used. Answer. Aeration is the process of mixing air and water together. It is used for stripping or removing volatile organic compounds or undesirable gases from water. List some common methods used for treatment of iron and manganese. Answer. The most common methods of treatment are sequestering, keeping the iron and manganese in solution, or removal by oxidation and filtration. Matched statements and terms. Excuse me. Fluoride. Added to water to prevent tooth decay. Filter. Normally contain layers of anthracite, sand, or gravel. Filtration. An important part of the process because bacteria may be protected by suspended particles and therefore be protected from disinfection process. Purpose is to remove as much suspended particles as possible. Contact time. The required amount of time to ensure that the chlorine has reacted with the microorganisms. Jar test. Used to determine the correct dosage of coagulant. Ion exchange, aeration, chloration. Any of these may be used to address iron and manganese removal. Clarifier. Purpose of this stage is to allow heavier matter to settle, also known as sedimentation tank. Chlorine contact chamber, also known as clear well. The location where chlorine is allowed to react with the water. Coagulation. The purpose of the stage is to rapidly mix chemicals. Detention time. The time that water remains in a sedimentation tank. pH. Adjustment of this parameter can often optimize the coagulation process. Flocculation. Purpose is to achieve particles that will readily settle out of water. Involves slow mixing of water in order to build particle size and density. Pre-chlorination. The water may be dosed with chlorine at this stage to remove potential odors, kill algae, or to control zebra mussels. Alum. For ferric sulfate, and polymers can be used for the same purpose. A commonly used coagulant chemical. Backwashing. Used to clean filters. Coagulant. Too much or too little of this will decrease the efficiency of the treatment process. The incorrect and unused statements. L guarantees the removal of cryptosporidium. That's incorrect. O, used to draw water into the treatment plant, also incorrect. T is used to pump water into the distribution system. That is false. And Y only used with groundwater systems. That is also false. And that is the drinking water treatment chapter.